Hello there, students. This is Mr. Von Ah, back at you with some more algebra. Today we're going to be talking about quadratic formula. All right, so students will be able to solve quadratic equations using quadratic formula. Now we've learned how to complete the square to solve quadratic equations. Now we're going to learn our last method, and you can use this formula for any quadratic equation. Okay, and it's especially useful, the quadratic formula is especially useful when a is greater than 1 and or b is an odd number. We can use completing the square for those, but it just becomes more complicated. All right, so take a look. If you see that a is greater than 1 and the b is odd, quadratic formula is the way to go. All right. So let's go ahead and dive right in to using quadratic formula. First, we need to know what the quadratic formula is. And really the quadratic formula is just derived from completing the square. Okay, so here's the quadratic formula in all of its glory. It is x, right, because we're solving for x. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now there's been songs written about this formula. I don't know any of them. But one thing to remember, a common mistake, is that students will just put the 2a underneath the radical part. Okay, remember it's all over 2a. Very important. Okay, so there's the quadratic formula. I could derive that for you, but it would be overly complicated and unnecessary. Okay, so there it is. All right, so here's an example. I have 5x squared minus 10x plus 2 equals 0. That's a quadratic equation. It is in standard form. Okay, if I tried to factor this by using zero products, it wouldn't work. Okay, and now notice that a is greater than 1. So because a is greater than 1, I'm going to go ahead and use quadratic formula. If a was just 1, if that 5 wasn't there, I'd just go ahead and use completing the square. It's quick and easy. Okay, but I see this as, even though this is even, a is greater than 1, so I'm going to go ahead and use quadratic formula. All right, so let's just go ahead and substitute our ABCs into our formula. Okay, so what are my ABCs? Well, let's take a look. A is 5. B is negative 10. And C is 2. All right, so there are my ABCs. Got to know your ABCs to do this. Okay, and by the way, it has to be in standard form for the quadratic formula to work. Okay? All right. So let's go ahead and substitute our values in. All right, so we have x equals, I'm going to get a different black marker. X equals, I like to say opposite of b, and here's why. If you say negative b, it gets a little more complicated. If I say, okay, negative b, well, what's a negative times a negative 10? It's a little more complicated, right? But if I just say, hey, it's the opposite of b, well, what's the opposite of negative 10? Positive 10. All right? So the opposite of b is 10. Put that 10 right there. And I'm going to get another black marker. Plus or minus the square root of b squared. All right, well, b again is just negative 10. I'm going to square that. Minus 4 times a, and what's a? Well, a is 5 times c, and c is positive 2. So I have, I'm just substituting my numbers in. And I'm going to go ahead and put that over the top. And remember, it's all over. Common mistake is for students to end it right there. Don't do that. All over 2 times a, all right? Well, 2 times a, and a is 5. So it's going to be 2 times 5. All right, so the first step is pretty straightforward, right? You just know your ABCs and you just substitute them into your quadratic formula. All right, now we just kind of crank the numbers through. All right, so I start inside my radical here. I have negative 10 to the second power. That means negative 10 times negative 10, which is, do you know? 100. You got it. So let's go ahead and write this stuff out. So 10 plus or minus the square root of, that's 100, minus, well, let's just see what happens here. So 4 times 5 is 20, and 20 times 2 is 40. So I get a negative 40, and that's going to be all over 10. 2 times 5 is 10. All right? So I'm just kind of cranking my numbers here. Okay, so I have one more thing to do in this radical. I need to subtract 100 minus 40. You know what 100 minus 40 is? Well, 100 minus 40 is 60. Okay, I have that all over 10. All over 10. Okay, now I need to make some decisions here. All right, so if I was simply going to get a decimal approximation for this answer, right, this is probably where I would stop, okay? I would just take the square root of 60. In fact, let's go ahead and do that. So the square root of 60 is approximately 7.75, approximately. Okay, so what that's saying is that 10, just bring it up here, x equals 10 plus or minus 7.75, I'm going to put approximately, all over 10. Okay? So what this is saying then is x equals 10 plus 7.75 over 10, or x equals 10 minus 7.75 over 10. And if I were to do that on my calculator, let's see, 10 plus 7.75 is 17.75. So I got 17.75 divided by 10, which is obviously going to be 1.75. I didn't need a calculator for that one. So x is approximately equal to 1.75, or x is approximately equal to 10 minus 7.75 divided by 10. Now 10 minus 7.75, is that 2.25? 10 minus 7.75 is 2.25 divided by 10 is 0.225. 0.225. All right, so those are my decimal approximations. Okay, if I was just looking for a decimal, and again, whenever you're answering questions on a test or a homework assignment, always look, how do they want the answer to be displayed? If they're looking for a decimal approximation, boom, that's where I'm stopping, and I'm just going to go ahead and approximate those answers. Okay, but if they're asking you to factor it or to solve it exactly, that means we're going to need to possibly go further. Okay, so here's what we need to do. We need to think, okay, 60. Does that have a perfect square in it? Now, do you remember the perfect squares? The perfect squares are those numbers that when you take the square root of it, you get a whole number. So, for example, 4. Square root of 4 is 2. Square root of 9 is 3. See, those are called the perfect squares. Okay? Can I factor out a perfect square from 60? Well, here's how I like to do it. It's just kind of an easy way. I just start dividing this number by a perfect square. So let's try 9. Let's see if 9 will work. So 60 divided by 9 comes out to 6.666666. That doesn't work. Okay. Let's try 60 divided by 4, because 4 is a perfect square. Ooh, and I get 15. So in other words, 4 times 15 is 60. And I like that because 4 is a perfect square. So watch this. I'm going to go ahead and say 10 plus or minus. Now instead of saying 60, I'm going to factor 60. I'm going to factor it as the square root of 4 times the square root of 15. Right? Because 4 times 15 is 60. Okay, and that's all going to be divided by 10. Okay. Now, I can do something with this square root of 4. Okay? Since it's a perfect square, I can just go ahead and take the square root of 4. What's the square root of 4? It's 2. So I'm going to go ahead and continue moving over. So this is 10 plus or minus. Square root of 4 is 2 times the square root of 15, right? All over 10. All right. Now, do we stop there? We keep on going until we can't go any further. All right, so let's take a look at this right here. This is 10 plus or minus 2 root 15 over 10. If I had something like this, I'll show you just kind of a little side example just so you can visualize it. If I had 1 over 2 plus, let's do this. If I had 1 over 4 plus 3 over 4, right? Could I write that as, could I add these up and just say 1 plus 3 all over 4? I could. All right, essentially it's going to be 4 over 4. So when I have the same denominator, I can go ahead and add my numerators. Okay, well if you look, I have the same denominator for both of these, right? This is just addition or subtraction. I can go ahead and split that thing up like this. I can show this as 10 plus or minus, or excuse me, 10 over 10, right? Because this 10 is underneath this 10, correct? So 10 over 10 plus or minus 2 root 15 over 10. See what I did there? I just split these two guys up because both of them are over 10. So I just split them up, just like I did here. All right, now here's the cool thing. 10 divided by 10. You know what that is? It's 1. So x equals 10 over 10 is 1 plus or minus, now 2 times root 15 over 10. Since this is multiplication, I can divide these guys. I can simplify 2 divided by 10. How do I simplify 2 divided by 10? Well, the greatest common factor between 2 and 10 is 2, right? 2 goes into 2 one time, and 2 goes into 10 5 times. And I still have that root 15 there, right? Do I even really need that 1 right there? 1 times root 15 is just root 15. So there's my exact answer. Okay? It can get pretty complicated at the end. Okay, so let's just back up. When we were here, it was pretty easy when we got to here, right? Then it got complicated over here. Well, what did we do? Okay, we just said, okay, can I factor out a greatest common factor? And we said, yes, we can. It's a 4. So we just factored 60 by 4 times 15. When we did that, we were able to take the square root of 4, which is now outside of the root, right? Because we want to get as much outside of the square root as possible. So we have that 2 outside of here. And then what we did is we just, we split this up. This whole thing right here is over 10. So we just split it into 2 different parts. And once we did that, we were able to do some further reduction. We were able to divide 10 over 10, which is 1. And we were able to divide 2 over 10, which is 1/5. Right? Right? So we were able to simplify it. Okay? So I'm not sure if Khan Academy, if they're going to ask you to simplify all the way. But any test that's going to ask you, now you know at least how you can move from here all the way to simplifying. Okay? I hope that was helpful. Make sure that you subscribe to my channel so that you get notified for any further videos that I make. And until then, may God richly bless you.